Hey y'all, this is Miss Falkenberg giving you the summary of what we did Tuesday, September 14th. First activity we did was completing worksheet 3 and turning that in physics. And in AP Physics 1 we turned it in and I just addressed completion. We discussed a couple things about slope and its meaning, and then also what a mathematical model is. And so if you're like, I don't know what that is, we want to talk about it a little bit, okay? Second thing we did is we started to make observations, and you can see in this video that I just found on YouTube, it's kind of a similar cart. We made, there's always an activity we lead into class with, okay, each unit. And this activity is about motion of a cart. And so they made observations about the motion of this cart. Clearly not my classroom. But we talked about that. What could we measure and how? So a couple observations they made. It's not fast. Seems like a constant speed, bouncy antenna, that's kind of excess, and straightish, right? Moves kind of in a straight path. So then we talked about what can we measure and how. It's not complex, pretty straightforward. The pendulum was definitely more complex. We can measure time with a stopwatch. And we can measure distance with like a ruler or a meter stick or measuring tape. And we talked about distance a little bit. How do we find distance? Well, really, if we measure the position at a certain time and a second position at a certain time, we can know the distance that it traveled. So really what we're measuring is position over time, okay? Now, we talked about another set of things as far as dependent variable and independent variable. It seems like time is always the independent or the dependent variable, position, how much time it is. But we had that conversation about meaningful slope. And if we did position versus time, position on the x, time on the y, we would get a slope that was time over position or seconds over meters. That doesn't mean anything. Hey, I'm moving so many seconds per meter. Really, what would be meaningful when we talk about speed is how many meters I've traveled in a second, or how many miles per hour, but that's just not the scale we're working with. So meters per second makes more sense. So we talked about, hey, let's put time on the x-axis and position on the y. Now, it's kind of funny. How do we do a set time? Right? How do we take distance measurements or position measurements at different times? And what I would say, I'm trying to get this, you would use a metronome. And so in class, we're going to have a metronome going at basically beat every second or 60 beats per minute. And your team's challenge, right, as far as their pre-lab, was to figure out how are we going to get the position every second, because it actually goes really quick, right? Are you going to use a video? How are you going to know when the second hits? Like, how are you going to pause, right? Are you going to use little pennies to put down every second, or a piece of clay every second, or make a mark on a piece of tape? Like if we had a long stretch of tape, making a mark with a whiteboard pen every second. That's what they were trying to strategize at the end of class, and they were trying to see if it would work. So when we get together on Wednesday, we're going to try to start collecting data, and they'll probably be testing their methods to see if it's accurate, or they might have a method and they're going to take data, and we're going to discuss what would be accurate data collection. So it makes it a little harder doing it with a metronome, but it gives us a slope that means something. Position over time, meters per second. So that is all. Bye.